So welcome everybody. This is a talk that I gave in October in New York. At Semantic, and it was about how to use taxonomies and ontologies to index your unstructured text, and then how to do analysis and do queries over the result of your indexing. So I'm going to talk about it today, and first I'll talk about a tool we call text triples. It's a toolbox and architecture for text mining, and I'll give you a first simple example of what we did in the supply chain management. Then the next thing I want to talk about is, because the first one was just using keyword search, but then we started getting into using taxonomies and ontologies to index text, and I'll give you an example that we did for the government of Malaysia, where we indexed scientific articles and artifacts. And then we took it even to the next step, where we now use external tools that make it very easy to create and add taxonomies, and use the output of those programs to do your analytics. Now, I was going to show you this morning what we did for a very large company that had millions of documents. I will talk about that company, but the demo is unfortunately down because I had a disk failure this morning. So what I'll do instead is I'll give you a presentation that is from the healthcare, or the domain of healthcare. Okay, so first about text triples. So what we've seen in people that are using IDF graph databases is that almost 60% of all of our customers are actually working with unstructured text, and they need to get things out of the text so that they can search it. And so we have available spiders that you can feed with URLs, with word lists and taxonomies, and using those, we'll go out on the web and find articles, for example, in the news by Google or Bing, or newspaper articles, business news, or we can go to social media. We can even do this in email, and what we'll do is we'll retrieve text. We get the text out of the things that we retrieved, which sometimes is much harder than you might think, especially when you get HTML pages. And then what you do is you give the text to an entity extractor that will get out of your text all the places, the people, the organizations, currencies, and we turn that into triples. So we say you have a text about Obama, that after this process, when we're about here, you will have a triple that says text 1000 has person Obama. Yeah. Then this triple will go into AllegroGraph. Then another thing that we do is that for each place name, we'll go out to the linked Open Data Cloud and find additional information about that place, like the latitude and the longitude, how many people live there, etc. For people, we'll go to DBpedia and Freebase and find more information about them. And for organizations, the same thing. So we enrich the data, and then ultimately we can do our visualizations and analytics. So one project where we applied that was for a car manufacturer that wanted to know very early on whether there would be any problems in their supply chain. As you probably know, all big car companies now do just-in-time logistics. Yeah, we try to avoid to have large inventories, but you just rely on your vendors to give you the stuff at the last possible moment. However, there's always the risk that something happens somewhere in the world and suddenly you don't have your stuff. So we created this semantic early warning system, yeah, that was able to answer questions like this, like which parts produced by a sub-vendor will be less available due to a flood in China, yeah, or which of our cars will be affected by political unrest in Thailand. Now, I won't read all the rest of the queries, but you get the idea. And in order for us to build this semantic platform about the supply chain, we needed to get a whole bunch of things together. Now, here's just a picture of the complexity of the supply chain, and I'm not even going to go there, but you get the picture. But what we needed to do is to get three clouds of data to come together. Yeah? So the first thing we did is we worked with the manufacturer to get the bills of materials for the products that were produced, plus the parts trees. Yeah? So that's kind of the hierarchy of the parts, plus all the names of the vendors that deliver the parts to you, and then partly your inventory and inventory predictions. Yeah, so that was one big cloud of internal data. Then the next thing we needed to do is we looked at the vendors, and then we worked hard to find the whole graph from vendor ultimately down to the producer of a particular part. Now this is really hard. In the military, there are requirements, and I think even companies like Walmart have these requirements where they actually require that a vendor knows exactly where each sub part comes from. But in the commercial world, it's kind of hidden information. So that was actually the hardest part of the project that we did here. And then finally, what we needed to do was to spider the web and business news sources for all the names of the suppliers, the countries where these suppliers come from, the commodities that we were trying to buy, or the commodities that make up the things that you need in your car, et cetera, et cetera. Yeah, and these things would obviously then all tie together, so that we ultimately could do queries like this, or actually write triggers like this. So, for example, there's a natural disaster warning. Now, first let me look at this picture here. Yeah, so you see here there's a particular part that was made by a particular company here that comes from Bangkok. Bangkok is part of Thailand. And in Thailand, there was a news article that talks about a flood and scarcity. Yeah? So here's part of the graph. And so we could write a rule that says, well, give a natural disaster warning for a particular vendor and part if anywhere in the world there is a text for a particular country, but this country, where there's a danger word like political unrest or a storm or an earthquake. So where you have a text with a country, where the text has a dangerous word in it, where this country has a place, where this place is a vendor, and where this vendor produces a particular part, and our first-tier spender sells this particular part to us. Yeah? So we would have this particular rule in place, and it would work for almost any kind of danger in the world and related to something that we need in our production line. So that was the first product that we did. But this was still all almost completely based on standard keyword extraction by standard keyword entity extractors. So, so we started working on a project where we actually could use our own vocabularies, taxonomies, and ontologies, yeah, and add it to entity extractors. And so we actually wrote that ourselves, and we applied it. And so this is still the same picture, except now we also store everything in Solr. And we did a project for the government of Malaysia. It's a website called Christie. And what the government wanted to know was how much it's spending on all kinds of research, and especially how effective certain scientists and organizations are, and whether they work together well enough. Now, this is obviously an issue for almost every government in the world. I mean, we spend so much money on research, but how much of that money actually comes back to society? Yeah. So that's basically the main question that you ask. And so in order to do this, we had to build this platform that had an ontology and taxonomy of all the important sciences and concepts in science. And we linked that to research output, patents, grants, etc. And then build a system around that to make it easy to do the kind of analysis that the government wanted. And so we use this particular taxonomy. So actually, almost every country in the world already has a taxonomy of all the concepts. In the US, we have the Library of Congress. But every country has these kind of taxonomy systems to classify the documents that get produced in your country. And so what we would do is we spend a lot of time to find every person in Malaysia that was somehow related to science, every document produced, and so huge class of documents. I mean, grants, proposals, papers, written patents, requests for a particular devices, etc. Projects and project management documents, funding events, facilities that have something to do with science, big equipment that was bought, like accelerators or whatever other equipment you might have, and then all the organizations. And everything in here was indexed using this particular taxonomy. Yeah. So this was actually by far the biggest part of the project, to get all that information together. And then ultimately you got a graph like this. Yeah. So this is just a made-up fake graph expressed in our graph, our tool to display graphs in RDF. Yeah. So you might have a research that's attended by Jans Aasman and Craig Novell. We both wrote this particular paper, and he's working for Stanford, and I was working for Johns Hopkins. Yeah, and he was also doing some other research for different topics. But the funding for both came from the NSF. Yeah, so you see that when you take all these sources and you classify that at some point you get a really extended graph where you might want to find connections in. And then here is the website that ultimately got built, and let me see if it's up and running. Is it actually running? Is it here? No. So here's the website that had all the information sources that I just talked about. If the internet will actually let us in. Yeah, so we have this huge database of all these different artifacts, from people to projects to documents, etc. And so if I want to search for something, just say security or whatever, then what it would do, it would go through every kind of object that we had. So when I searched for security, there was 6,000 documents that you can look at. And there were about 575 projects about security, 492 people in the country that specialize in security, about 30 patents, about 138 organizations, lots of products that ultimately came out of the research, facilities that do research into, equipment bought for this, technical markets, and websites. Yeah, so it's almost like a faceted search over all the scientific knowledge in your country. And you could look at this as a keyword, and that's what we did, or you can look at it as a taxonomy. So when we look at the taxonomy for the word security, then I could say, well, let's just look at food security, yeah? And I have no idea whether there's anything there. This is about food security, and now we see there's only 134 documents and a few projects and a few people that are all involved in that. Yeah, so that was a project that did both keyword search, but also for each keyword would go into the taxonomy, find all the related topics, and then do a faceted search that gets displayed in this. Now, this is only a small part of the entire system, because with all the papers and publications, we also can look at the graph of authors and how they're related to particular organizations, the kinds of research they do, et cetera, et cetera. But you probably get the points. Okay, so let me go further with my presentation. Here. Where are we? Oh, we are here. And so for the system that I just showed you, we wrote our own entity extractors and taxonomy extractors. But we are a company that specializes in an RDF graph database and not so much in natural language processing. So we work with partners for that. One partner that we work with is Smart Logic from the UK. They have a very advanced tool to make it easy for large enterprises to collaboratively create taxonomies and ontologies. And then they can use those to do entity extraction on unstructured data use those ontologies and taxonomies to classify unstructured text. But the new thing is now that they also now can export what they index as triples into AllegroGraph. So now if I have a patient record with where the patient record talks about a patient has a mood disorder, then now Smart Logic will add new triples to AllegroGraph. Okay? So here's roughly the idea. You have a lot of text, and you have an engine that has their own standard entities. So so Smart Logic is a whole entity extractor, which means it can recognize people, it can recognize organizations, countries, currencies, whatever you have. And it has a bunch of taxonomies. Yeah? So this is what you just come out of the box. But you and your enterprise can add the own entities that you're interested in, and you can build your own internal enterprise taxonomies. Yeah? And you can feed both into Smart Logic. The new thing for Smart Logic is that you can now do this with their direct tools, or you could have existing taxonomies in SKOS or other representations and import that directly into Smart Logic. Then you can take your text and you feed it through the engine, and now what you get out is the standard entities like place names, but also if you're a car manufacturer, you get the entities that you're interested in, like part numbers and other things, and you get the standard classifications, but also your classifications. Now all of that goes as triples into AllegroGraph, and then again we can enrich the data with public linked open data or with your enterprise linked open data. Yeah, so information that you don't want to make public, that you really would like to add to the information that you get out of unstructured text. So here's a picture of this new integration of AllegroGraph and Smart Logic. So here is the product called Semaphore, which has this ontology server, a search engine, and a classification server. And everything is now exported or imported in and from AllegroGraph. So you can have a bunch of text. It goes through their engine, and out comes triples. And now you can apply your rules, your reasoning, Sparkle, Prolog, or whatever you want, yeah, and do your analytics. So we have applied that in several projects. And the first project that we did it for was a European organization for economic development that has hundreds of different types of documents. And here you see a nice picture: bibliographies, summaries, graphs, maps, treaties, conference paper, mail, letters, speeches, minutes, etc., in 8 or more different languages. Yeah, and they had their own taxonomy of all the concepts that are relevant to this organization, with the added difficulty that they had to do everything in 8 different languages, which in itself is a really tough challenge. Yeah. But what then Smart Logic can do is it can take the taxonomy of this organization and then turn it into, or index it with the taxonomy and turn that into the triples. And then what we did at front as an additional thing is build kind of a spreading network activation algorithm. Yeah, so that if I was looking for a particular term, and I'm assuming now that people on the phone all know how SKOS works, yeah, where if you were looking for a particular word, it would look for the topic in the text and all the related topics, and then it will also look at the broader topics but give it less point, and then ultimately go up the chain and then go sidewards again. So it's like a recursive algorithm, so that if you were looking for a particular topic, that you could get a ranked list of documents back were as close as possible to the original topic or set of topics that you were looking for. Now, unfortunately, after my disk crash, I can't show this. So I would like to show you another project that we did together with Smart Logic. You might have seen this before, but it's about something we did with patient records from the UK. And so we called this project False Trips and Slips. And it was patient records of people that were over 75 that fell and that had to go to the hospital. Yeah, I mean, for all the people on the line, once you get over 75, you will fall about once every 3 years, yeah, and 4 out of 10 times you will have to go to a hospital, where someone will make a note of what happened to you. Now we needed to index those notes. Yeah, so we started adding some new taxonomies and vocabularies for things that are risk factors, plus we used some existing ones. So the existing ones that we used were mesh and SNOMED, the most, well, probably the most well-known taxonomies and ontologies out of the healthcare world. But then what we added for the taxonomy was things about age and the housebound status, or whether the person was living alone, some historical factors about the patients, some physical deficits, some environmental hazards, like, well, they had a very steep chair, or this very steep chair doesn't have a handrail, etc., etc. And then obviously we would use mesh and SNOMED to look at the text and find all the drugs that people were using. Yeah, so we could go here. And then we would do the indexing on the unstructured text, both of doctors and of the doctors, of the at-home carers, and the social workers. Yeah, and we created these additional hazards. So what you see here is a picture of a smart logic tool called Semaphore, where they imported mesh, but then what we added is something that's not in mesh, which is environmental hazards. Yeah, where we added some additional factors, several hundred as a matter of fact. Yeah, and then ultimately we took all these unstructured notes, fed it through the engine, got it in here, and did our analysis. Yeah, so the demo that I'm going to give, yeah, is actually partly from the linked open data cloud, and again I'm assuming that everyone in the audience is now familiar with the linked open data cloud, and I'm actually using 5 data sets out of this cloud: linked clinical data, drug banks, diseases, side effects, and daily medicine. But here's a better picture. Yeah, so these things, the red ones, I downloaded from the web. Then we had our 3,000 patient records that were all indexed with mesh and SNOMED, but all the unstructured text in the clinical trials and diseases and side effects is also indexed with SNOMED and mesh. Yeah. So I actually now can look at a particular patient record. I can index it. I can find a particular drug that the person is using. I can look in the clinical trial for the side effects of this, more information about the drug, and then I can look at the side effects. So I can look here at a particular drug and can find out if this drug in general makes you dizzy, yeah, or lowers your blood pressure. Okay, so here are all the data sets that we had available. Yeah, I would say this is the enterprise data and this is the public data. And let me give you the demo. So if I have it up and running already here. Yes, so it's a demo set that I make available, and some of the people in the audience already probably have seen this demo. So in general, what it allows me to do is to search for any particular word that you might be interested in. Mood disorder. I actually don't know if we have that. Okay, so here's some things with mood disorders. Yeah, so here's some clinical trials. I could look at a particular clinical trial. And then we see it's about alcoholics with anxiety and depression. This clinical trial is about these particular drugs, these particular side effects. I could click on a drug and I go into the drug database. And you see the chemical formula and everything else that you might want to know about this particular drug, the pharmacology, the mechanism of action. I could look at other clinical trials that talk about this particular drug. I could go into particular side effects or diseases, and here is the disease database. Anyway, you get the point. I can go on and explore that. I can actually also explore this on the screen. Yes, so I'm choosing a few predicates that are related to the classes of things that are on the screen. So we see here right now that we have offers, side effects, and trials on the screen, and only 2 predicates: discusses drug, discusses side effects. So I can actually do this. Oops, I can take this one. And I can start looking at the relationships between these particular trials. So there's 3 clinical trials about mood disorder. And these 2 were related to blood dyscrasia and depressive symptoms. I can take any other, so what would be another thing that we could look at? Dizziness, if that's a word. How do you write dizziness? Low blood pressure. Oh, that's a 10 points. Anyway, let me just take a drug like Prozac. Yeah, take some clinical trials about Prozac, and we just see these things get instantly already folded into here. I could. So I'm not going to do a full graph demo now. You get the point. But let me go to more the clinical. Sorry, the patient records. So I can go to a previous picture that I had where I have a patient note, yeah, for a guy called Brady Tatum, who is the patient, and here's actually the note. One of the things in here was the hypnotics, and here's a clinical trial about cardiovascular diseases. And one of the things that you might be interested in is to see if there's any relationships between the 2. And you see here we had this clinical trial here, and so there's a complex relationship between those. But at least you can see that at some point this hypnotic that this person is using is related to trials that talk about coronary artery disease or other things. We might start looking then for dizziness or other factors, but I hope I've kind of shown you how you can index your patient records with Meshnome and other things, and then ultimately link it to data that you have in completely different databases and find interesting connections between the 2. And I think I should go back to my presentation here. And so we think that a case like this could be used in many different places. We've done all kinds of analytics with this data already, but again, this is not a healthcare morning. I just wanted to show you how this technology makes this kind of analytics possible. And with that, I'm going to look at the questions that I've had so far this morning. One question is, can you do this also with something, another graph database like Neo4j? Well, you probably could, but then the Neo4j people would have to become an RDF graph database. What you might have noticed is that all the data that I'm using here is all standards-based. Yeah, we're talking about unique concepts like a particular drug. We're talking about taxonomies, ontologies, and relating data together. Graph databases are usually not made to make things work together, but RDF graph databases are. Yeah, the mechanism of linked open data. Does this tool do any uncertainty reasoning well, actually, yeah, one of the webinars that you might expect of us probably in January or February is where we start working with Bayesian belief networks in R. Yeah? So we're right now looking at machine learning and combining that with AllegroGraph. We already have a few systems that use AllegroGraph as the data source for machine learning, but we also have interesting patterns where people can look at a particular configuration of a person or an organization and do some Bayesian inferences. Is this healthcare data set available? Yeah, it's available. If you go to our website and you go to, if you go here, let me see if I can find it easily. You go to Graph. Then at the bottom, I believe, downloads. Oh yeah, graphhealthcare.zip. Yeah, if you want to play with this file, look at the screen. There's the file that you could use. Can you say something about Graph Builder plus text? Yeah, we. I don't know who's asking the query, but anyway, so we are working with Intel that is creating a new product called Graph Builder that makes it very easy to get, much more straightforward to get graphs out of big data. So if you have a big data system with lots of data, and especially unstructured data, then they have a tool that lets you allow to go through the text and very quickly create triples out of that. It's if you go to graphbuilder.org, you find more information about that. And ultimately, this demo will be is recorded and will appear on our website in a few days. Yeah. Okay. Thank you.